Hello, Excel Geometry. So what we're doing today is, the lesson is going to be about reviewing factoring. But tonight's homework, you will be preparing for your assessment tomorrow. So you will have a review that you're going to go over to prepare for your assessment tomorrow. The homework that is attached to this factoring, all the additional problems, I would like you to complete for Thursday, so you have ample time to do that. Your assessment will be due tomorrow at 8 p.m. at night. So you guys are welcome to come to my office hours tomorrow and ask questions on the review homework that you're going to be working on tonight. So what we're going to do right now is we are going to just go over some basic factoring review problems to make sure that we kind of recall how to factor. So the first example that you're going to look at is what I'm going to say is a binomial, and it's a binomial because we have two unlike terms, an x squared and a 3x. Now, anytime, whether you have a binomial, a trinomial, any amount of terms, the best thing to do when factoring is to look for a greatest common factor, which is our GCF. That is always going to be the first thing we should do when we are factoring any type of problem. Now, in an example like this, they say, well, what's told your GCF is x, because x squared and 3x share that value. Now, what I want to emphasize is that when we factor is the opposite of distributing something. So when we distribute, we multiply. Therefore, if we're doing the opposite, when we're pulling out a common factor, we are going to be dividing every term by that factor. Meaning, if I'm taking this x out, I am dividing every term inside by that x value. And if you'll see, that's where one of these x's, you have an x squared over x, one of them on the top cancels with the bottom, and then these two x's cancel, and that's how you get x times the quantity x plus 3. All right? So be aware that when we factor, we're doing the opposite of multiplication. All right. Now let's look at our next problem. Our next problem is a trinomial because we have three unlike terms. X squared minus 4x plus 3. Now when we look at trinomials are usually in the form ax squared plus bx plus c. And there's going to be two methods of factoring here based on what your a value is. Now right now our a value is 1, and we can see that right up there. Our a value is 1. And when our a value is 1, we can do something called basic factoring. We can say what adds to -4 and multiplies to a positive 3, which is what's written here. What multiplies to 3 and adds to 4. Now, if you take a look at that, if I want to add to a negative and multiply to a positive, then both signs must be negative. So that's where we're getting, right here, x minus 3 and x minus 1. What we do is we create the two bubbles, like we said. We know that x and x have to be the first terms in order to get that x squared there. We know 3 and 1, they add to a positive 4 and multiply to a positive 3. But in order to add to a -4, both of them must be negative. And that's where we're writing x minus 3, x minus 1. This is basic factoring, but it can only be used when our a value is 1. Now our next problem is slightly different. This a does not equal 1, and that is important. So we need to know in this case a does not equal 1. Over here it was helpful that a did equal 1. When a does not equal 1, we need to approach this in a completely different way. And depending on what algebra teacher you had, they might use a different name. Some algebra teachers use Billy's method, some say the rainbow method. But what it really is we're going to take our trinomial, we're going to break that middle term into two terms, and we're going to factor by grouping. So, for example, here it says multiply 2 and -4. Why some people call it the rainbow method is because they do this. You multiply your leading coefficient by your constant. Your leading coefficient in a quadratic is always attached to your x squared term. Your constant does not vary, therefore there's no variable attached to it, so it's whatever stands alone. So 2 times -4 is a -8. Then we say we need two numbers that add add to negative 7 and that multiply to negative 8. And when we look at that, those two numbers would be negative 8 and 1. So what you see here is this negative 7x is now broken up into two x terms. All right, so that negative 7x is now broken up into these two x terms, negative 8x plus 1. So that's what we're doing. We're taking that middle term and we're breaking it up by saying what numbers multiply to negative 8 and add to negative 7. Once you get here, we factor by grouping, meaning we group the first two terms together and the second two terms together. And in the process of factoring by grouping, we factor out a GCF from each group. Now, if you look at this, the GCF of 2x squared and negative 8x is that 2x. That's factored out. And remember, when we factor out a GCF, we divide each term by that value. So 2 divided by 2 cancels to 1. X squared divided by x becomes just x. Then I have minus 8x. 8 divided by 2 is 4. X over x cancels out to 1. Now, this is very important, and I want to emphasize, when factoring by grouping, we have to remember 1 is a factor of everything. So if 1 is the GCF, 1 needs to be factored out. So if I look here, 1 is the GCF of 1x and negative 4. So that 1 must be factored out, and we must show it's there, because 1 is a factor of everything. If I factor out the 1, I'm left with the x minus 4. Now, if you take a look at this, we now have a common binomial factor, meaning binomial means two terms. I have a common binomial factor that you can take out. So we have that common binomial factor that we can take out, and what remains is my 2x plus 1, my second factor. And that would be your final answer. Now, our last method is somewhat different. This is actually called factored. We have x squared minus 4. Again, binomial. It's a binomial because we have two unlike terms. But when I look at this binomial, it does not have a common GCF other than 1. But what I do notice is this is something that we call the difference of two squares. So let's write this down. Difference of two squares. And what's the difference of two squares? That means I see what is being squared. The difference of two squared would say a squared minus b squared. I have two values that are being squared, and that would equal a plus b times a minus b. So in this example, you'll see x squared minus 4 squared. That's the same as writing. If I rewrote this, that would be equivalent to x squared minus 2 squared. So x is being squared and 2 is being squared. So that means when I write those two bubbles, I say, okay, well, wait a minute. I have x and x because I have an x squared term. X is being squared, 2 is being squared. That's where I'm getting my x plus 2, x minus 2. All right, everybody? This is reviewing some of our problems. So I'm going to do one problem from each type now as we go. If I can see if I can have one of each. Let's see. Yes. So let's start with, we can start with number 1. Let's just start with number 1. Now this I know is the same method as B up here, and my A value is equivalent to 1. So all I have to do in a problem like this, I have a trinomial where my A value is equivalent to 1. I have to look at my middle term, and I have to look at my last term, and I need to say what adds to negative 9 and multiplies to 20, positive 20. Now I have an x. I know I make my two bubbles. I know if I have an x squared, both first terms have to be x, because x times x would be equivalent to x squared. If I have to add to a negative 9 and multiply to a positive 20, that means both of my values must be negative. To multiply to a positive and add to a negative, they both must be negative. And if I think about this, my answer would be 4 and 5. Negative 4 times negative 5 is a positive 20. Negative 4 plus negative 5 is a negative 9. All right, that's our nice basic factoring method because A is equivalent to 1. All right, guys, the next thing we're going to do is I would like you to go to the next page because there's a lot of these problems. I want to make sure that we can approach some of the other problems. So let's take a look at 44. Okay, let's take a look at this problem here, 44. Here, let's try to do a more challenging problem. Now, here my A value is 10, so I cannot use the method I used before. So we need to use, when we go back to the sheet, we need to use C, method C here, factor by grouping. That means we're going to have to make a rainbow by multiplying our leading coefficient by our constant. So I take a look at this. I would start by saying I'm doing 10 times 3, which is 30. And then I'm going to say what multiplies to 30 and adds to 17. Now, if I think about that, it's 15 and 2. You take that 17 and break that 17x into 15x plus 2x, because 15x plus 2x is equivalent to 17x. And then I bring down my first and my last terms. So first and last terms get brought down. Now we group. I group the first two terms together and the last two terms together. And I say, what is my GCF? 10 and 15 share a 5. X squared and x share an x. Remember, I have to divide when I factor because factoring is the opposite of distribution. So 10 divided by 5 is 2. X squared divided by x is x. Plus 15 divided by 5 is 3. X divided by x cancels out, so that would be 1. Now if I look at my next, I have a 2x and a 3. And remember, I'm going to emphasize this. 1 is a factor of everything. So even if your GCF is just 1, you need to show that you're factoring it out. So I have to show I'm factoring out that 1. And what remains? 2x plus 3. Because 1 is a factor of everything. Now I have a common binomial factor. Common binomial factor. So I can actually pull that out. That common binomial factor is x plus 3. I can factor that out. And what would I be left with? I would be left with 5x plus 1. And this would be my final answer. All right. Okay. Now I'm going to flip this over now. This is the second page. So guys, let's do one more. All right. Actually, I might do two more. Let's take a look at 56. Now, this is the difference of two squares. I have two terms and they're squares of something. Now, you might not think about it initially, but it definitely is. Now, if you think about this, factor by the difference of 2 squared. We're looking for what A is and what B is, meaning what's being squared in the first term and what's being squared in the second term. So let's see. How do I get x to the fourth? Well, x to the fourth is technically x squared squared. Because if I'm multiplying 4 x's here, that's the same as doing x squared times x squared. Minus 121, the square, what's being squared there is 11 squared. So now you have to look inside the parentheses. Whatever's in my first parentheses is my A. Whatever's in my second parentheses is my B. So when I write this, I have to say whatever's in the first parentheses is the first term of both of my binomials. And then I'm going to have a plus and a minus, because that's our factor form of difference of 2 squared. And whatever's in the second parentheses will go next. Mm-hmm. All right, now let's look at 59 too. Actually, I might do a couple in here. We can start with 59. 59, let's take a look at that. this is a binomial, and I see a cubed and an x. Now, in this binomial, I went right to the difference of two squares because the GCF of it was 1. But down here, if I have a GCF other than 1, I need to factor it out first. So if I look at 3x cubed and 12x, I'm going to first factor out that GCF of 3x. If I take out the 3 and 1x, I have 2 x's remaining, so that's an x squared, minus, if I take out the 3 from 12, that's 4. If I take out the x over x would cancel to be 1. So I get 3x times the quantity x squared minus 4. Now here, we should see this is the difference of 2 squared. Now we know it's difference because difference means subtraction, and I can see two values that are being squared. Here I have x squared minus 2 squared. X would be my A, 2 would be my B. So now I can factor that one step further. I can say 3x times x plus 2 and x minus 2. And that would be my solution. Now, the only ones you're going to have to be a little careful with would be something like 55. In 55, there's no GCF other than 1, so we cannot factor out a GCF. But we have to see what's being squared. The first term is 4x squared. This is actually going to be that value of 2x being squared. Minus y squared, I get y being squared. Now we can use this method because difference is subtraction. So the difference of 2 squares, you would have then 2x plus y and 2x minus y. Remember, this formula can only be used with subtraction. It's the difference of 2 squares. So, for example, with a problem like 53, it's unfactored. You cannot factor. We cannot factor the sum of 2 squares. Because that's a plus, we cannot factor it. It only works with the difference of 2 squares, which is our subtraction. All right, guys, I hope that helped. Remember, this is going to be due Thursday at 8 o'clock, the remaining of these problems. If you have any questions, please come to Canvas Conference, and I'd be happy to answer them. I hope you're doing well, and I hope to speak to you soon.